Welcome, travelers, to Adventures in Security. In this lesson, we explore elements of secure cloud architecture and design. You can download the video script, including bibliography, from the link in the description. In this video, we're going to break down cloud concepts, architecture, and design in a way that connects technical ideas to real-world security decisions. We'll start with the basics of what cloud computing is, then move into how cloud systems are designed for scalability, resilience, and governance. From there, we'll focus on one of the most important realities of cloud security. Identity is now a primary control plane. That means who or what is requesting access often matters more than where the request originated. We'll also examine core network protections, including network security groups, traffic inspection, and geofencing, and then connect those controls to zero-trust networking. Finally, we'll close with the most common cloud threats, such as misconfiguration, weak identity practices, and insecure APIs. By the end, you should be able to explain not just what these cloud concepts are, but why they matter for secure architecture and day-to-day operations. Cloud computing is best understood as a model for delivering computing resources as services over a network. According to NIST, cloud systems are characterized by on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. In practical terms, that means organizations can provision servers, storage, platforms, or software quickly without owning all of the physical infrastructure themselves. You should also understand the three major service models. Infrastructure as a service gives customers the most control over virtual machines, storage, and networking. Platform as a service abstracts much of that infrastructure, so developers can focus on building applications. Software as a service delivers complete applications to end users. Deployment models also matter. Public cloud is shared infrastructure offered by providers. Private cloud is dedicated to one organization. Hybrid combines multiple environments. And community cloud supports organizations with shared concerns. One final concept is the shared responsibility model. The provider secures the cloud infrastructure, while the customer remains responsible for how identities, data, applications, and configurations are managed inside that environment. Architecture is the blueprint that explains how cloud services, users, providers, and controls fit together. NIST's Cloud Reference Architecture identifies major roles such as the cloud consumer, provider, broker, carrier, and auditor. That framework helps us think systematically about who delivers services, who uses them, and who verifies compliance and security. Good cloud design also requires resilience. Because cloud environments are distributed, architects should plan for redundancy, fault tolerance, backup, and recovery across zones, regions, or services. Security must be embedded in that design rather than added later. That includes workload segmentation, protected management planes, centralized logging, and policy-based governance. Another key practice is automation through infrastructure as code, which reduces manual error and makes environments easier to review and rebuild consistently. CISA's cloud architecture guidance also emphasizes secure migration, data protection, and posture management. So, when we talk about cloud architecture, we are really talking about building systems that are not only scalable and efficient, but also observable, governable, and resilient under attack or failure. Identity and access control is one of the most important pillars of cloud security because nearly every action in the cloud begins with an identity. That identity may belong to a user, an administrator, an application, or an automated service. Authentication answers the question, who are you? While authorization answers, what are you allowed to do? In cloud environments, those decisions are often made through centralized IAM systems that issue roles, permissions, policies, and temporary credentials. Federation is also critical because organizations frequently rely on a central identity provider to let users access multiple cloud services without separate accounts everywhere. NIST's Digital identity guidance emphasizes identity proofing, authentication, and federation as core parts of digital trust. From a security perspective, the most important design rule is least privilege. Only grant the minimum access required to perform a task. Access should also be reviewed continuously because permissions tend to expand over time if they are not managed. In short, strong IAM is the foundation for protecting cloud resources, and weak IAM quickly becomes the fastest path to compromise. When we talk about user access, we mean how human users, such as employees, contractors, and partners, securely log in to cloud resources. Best practice starts with unique user identities, so actions can be traced to a specific person. Shared accounts weaken accountability and should be avoided. Multi-factor authentication is also essential because passwords alone are too easy to steal, guess, or reuse. Role-based access improves control by assigning permissions based on job function instead of granting permissions one by one. This makes administration cleaner and lowers the chance of over-permissioned accounts. Modern cloud environments also use conditional access, which means access decisions can consider more than just username and password. Policies may evaluate the device being used, the sign-in risk, the network, or the user's geographic location. Finally, access is not a one-time event. Organizations need a joiner, mover, leaver process, so users receive appropriate access when they start, change roles, or leave. Without lifecycle discipline, dormant or excessive accounts become an easy opening for attackers. Privileged access deserves special attention because administrators can change configurations, create identities, disable logging, and access sensitive data. In other words, if privileged accounts are compromised, the attacker may gain broad control very quickly. That is why organizations should separate administrative identities from everyday user identities. An administrator should not browse email, open documents, and manage production systems from the same account. Another best practice is just-in-time access, where elevated permissions are granted only when needed and for a limited period. Closely related is just enough access, meaning administrators receive only the specific privileges required for a task, not blanket authority. High-risk actions should require stronger authentication, approvals, and detailed logging. Session monitoring can also help investigators reconstruct what happened during sensitive administrative work. Finally, emergency or break glass accounts must exist for outages, but they should be tightly controlled, monitored, and tested. In cloud security, privileged access is where convenience must give way to discipline, because these accounts are prime targets for both external attackers and insider misuse. A common mistake in cloud security is focusing only on people and forgetting that applications, scripts, containers, and cloud services also need access to resources. This is called service access or machine-to-machine access. For example, a web app may need to read from a database, or a workload may need to pull secrets from a vault. The secure approach is to give that workload its own managed identity or service account, rather than embedding passwords, API keys, or certificates in source code. Microsoft's Managed Identity Guidance specifically notes that managed identities can replace secrets and certificates for service-to-service dependencies. That matters because hard-coded credentials are easy to leak through code repositories, logs, backups, or misconfigured storage. Service identities should also follow least privilege, meaning each workload receives only the exact permissions needed for the resources it uses. Short-lived credentials are better than long-lived static keys, and service permissions should be monitored just like human permissions. In a modern cloud, machine identities often outnumber human users, so weak service access controls can quietly create a very large attack surface. Even though identity is central in the cloud, network security still matters. Network controls help limit exposure, reduce lateral movement, and enforce clear communication paths between systems. One example is the Network Security Group, which Azure describes as a way to filter inbound and outbound traffic between resources using rules based on source, destination, protocol, and port. In practice, these rules should follow a deny-by-default mindset. Allow only the flows that are necessary. Traffic inspection adds another layer. Tools such as cloud firewalls, intrusion detection systems, and packet mirroring help security teams analyze traffic for threats, policy violations, or anomalies. Google Cloud's packet mirroring guidance shows how mirrored traffic can be sent to inspection appliances for deeper analysis. Geofencing adds contextual control by restricting access from certain locations. Microsoft Documents named locations based on IP ranges, countries, and even GPS-assisted signals in some scenarios. Together, these controls help organizations narrow exposure, detect suspicious behavior, and make network access more intentional rather than open by default. Zero Trust networking represents a major shift from traditional perimeter-based security. Instead of assuming that users or devices inside a corporate network are trustworthy, Zero Trust assumes no implicit trust should exist based solely on location. NIST describes Zero Trust as moving defenses away from broad static perimeters and toward users, assets, and resources. That means every access request should be evaluated using context such as identity, device health, policy, workload sensitivity, and session behavior. One practical outcome of this model is microsegmentation. Rather than placing many systems on a broadly trusted network, organizations divide environments into smaller protected segments so that a compromise in one area does not automatically expose everything else. Zero Trust also reinforces least privilege, continuous authentication, and continuous monitoring. Access is not granted once and forgotten. It is assessed and reassessed. In cloud environments, Zero Trust is especially valuable because resources are distributed, users work remotely, and workloads communicate across many services. So Zero Trust networking is not just a firewall strategy. It is a design philosophy that treats every connection as potentially risky until it is verified. The most common cloud threats are often not mysterious zero-day attacks. They are usually failures in basic security discipline. Misconfiguration is one of the biggest problems, especially in fast-moving cloud environments where settings can change rapidly and drift from approved baselines. CISA has warned that improper cloud security configuration has introduced substantial risk in real incidents. Identity compromise is another major threat. Recent CISA reporting notes that attackers increasingly exploit vulnerabilities, steal credentials, and forge tokens to compromise cloud infrastructure. Access control failures are also critical. OWASP continues to rank broken access control at the top of major security risks, and excessive permissions remain a common pathway to abuse. Other recurring threats include insecure APIs, exposed administrative interfaces, leaked secrets, and software supply chain risk. CSA's top cloud threats work also highlights misconfiguration, IAM challenges, insecure interfaces, third-party risk, and advanced persistent threats. The lesson here is simple. Cloud threats often exploit complexity, speed, and weak governance. The best defense is strong architecture, disciplined IAM, continuous monitoring, and aggressive reduction of unnecessary exposure. To conclude, cloud security is not a single tool or setting. It is the result of many design decisions working together. Strong cloud architecture gives you resilience, visibility, and governance. Strong identity and access management ensures that users, administrators, and services only receive the access they truly need. Strong network security reduces exposure and helps detect suspicious traffic. Zero Trust ties these ideas together by requiring continuous verification instead of blind trust. And finally, understanding common cloud threats reminds us that attackers usually take advantage of weak fundamentals, such as poor configuration, excessive permissions, exposed secrets, and weak monitoring. So the big takeaway is this: secure cloud design is proactive, not reactive. It starts with the architecture, continues through identity and network controls, and depends on ongoing review, logging, and policy enforcement. If you remember one phrase from this presentation, let it be this. In the cloud, security is continuous. It is designed, enforced, monitored, and improved over time. That's it for this video. If you learned anything, please remember to give us a thumbs up and subscribe. And until next time, be careful what you click.